Back in 1992, 1993, it wasn't even called lubricant varnish. They were just called lubricant deposits. So we were actually working on solving the problem of lubricant deposits before varnish was even coined. So yeah, there has been a great awareness over the years. And in 2005, actually, GE was the first company to issue a technical information letter, a TIL, that said this is becoming an issue in industry. And although we do not know the cause of varnish, these electrostatic machines are offering some mitigation support. So that was the 2005. And then, 2009, we fully understood the cause of varnish, and the solution really had nothing to do with electrostatics. But we're living in this moment now where the industry is somewhat confused and, doing things incorrectly, or could be doing things in a better way. So there's a great deal of confusion in the industry right now. So I'd say there's been enlightenment, advancement, but depending where you go and who you're talking to, there's a lot of confusion as well. There's a lack of awareness, and engineering school doesn't teach people about lubricant chemistry or oil analysis. So depending on our starting point with a new user, it could be like they know nothing, or they're actually very sophisticated. So we're seeing pockets of excellence and pockets of really just becoming aware. So, to step back from that just for a second, I'd say you could sort of classify people into a couple different categories. There's those that are doing nothing. There's those that are doing the wrong thing. And there's those that are implemented a solution that's extremely effective, and these users are operating in a completely different paradigm with incredible environmental and economic savings. So, I sort of get frustrated. It was like, well, why isn't everybody there? It just seems logical that everybody would be there. But we see so many people in the do nothing or doing the wrong thing phase that it's a challenge to overcome, and it really has to go back to education. The problem with lubricant contamination is that it exists in multiple forms. So you got to ask yourself, before you deploy solutions and spend maintenance dollars, what form physically is the contamination that I'm trying to remove in? And I see this every day. Gas turbines or steam turbines are running at elevated temperatures, and at elevated temperatures, the root cause of failure is dissolved. So is your maintenance strategy doing anything to address the dissolved impurities, the waste molecules that shouldn't be in the oil in the first place, right? And inevitably the answer to that question is no, or even worse, I've implemented a solution that only deals with insoluble or solid material, and at operating temperature that machine is doing nothing. So I see this mismatch between the form that contamination is in and what machines or maintenance strategies are being used to remove that. The beautiful part about SVRs is it doesn't matter, because we are doing both. When you operate with an SVR on your system, it doesn't really matter what the pressures, temperatures, or flows are. We are going to address both sides of the equation at the same time, and magic's going to happen as a consequence. When you address both sides of the equation with SVR, this is incredible. And inevitably, all the other solutions in the market are doing one side or the other, and implementing not only a half a solution, but maybe a 0% solution, depending on what your operating temperatures are. This whole SVR started with a problem. There was a problem that was causing gas turbines to fail. And this is in 1990. It was causing 4 complete failures per year, costing $2 to $4 million per failure. Then the production losses were on top of that. And when my dad started investigating this, what he found out was that 100% of the maintenance budget was being spent not on the problem, and that the oil testing and oil maintenance was strictly focused on particulate removal. And while essential, the root cause of failure in this case was chemistry. But when you look at chemistry management across the industry with lubricants, everybody is basically at varying levels of failure, and you're trying to figure out when to change your oil before that failure happens, but it's really not something that you can safely predict. So, ion exchange resin technology, it's from the water industry, right? So this is how water treatment plants work. To use this outside of that application was considered crazy, and we were told we were crazy by the inventors of ion exchange resins at Dow Chemical. So what's interesting is by applying an adapted solution from the water treatment industry into the oil application, now we have brought for the first time in history the ability to manage the chemical properties of lubricant in addition to the physical properties. So that was the magic in how it started. So many people will be surprised to learn that the last 1,000 SVRs that were made were based on a design of 100 that were installed on a fleet-wide basis in 1992. So while some people are looking at SVR as something new, its design has been in place since the early 90s. It's quite an exceptional case history. It's sort of like getting a smart kid at class to do your homework. It's just not going to work, right? You might get away with it once or twice, but eventually you're going to get caught. And really, people need to go to first principles on this. And if users, individuals, when you want to solve a problem, go down to first principles, understand what is the problem. And people have skipped this step. And someone comes in their front door and offering them something that's shiny, some lights on it, and this is a solution to my problem. How do you know it's a solution to your problem if you don't even understand what your problem is? So there's a misfiring here and a misallocation of resources. Like really, 100% of the maintenance budget right now is likely not being spent on the root cause of failure, right? So, okay, understand the issue. Understand the issue's chemistry. What can I do to manage the chemistry properties of my lubricant? Does this product that I'm evaluating manage those? And as soon as you look at it that way and in that light, everything is clear. And users are now empowered to make decisions that are going to be much more effective, and they're going to look good out of it. People don't want to make bad decisions and buy the wrong system, but without understanding what the cause is, the root cause of failure, what the root cause of failure is with the lubricant and the machine, then you become enlightened, and the solution is quite straightforward actually. And just to go into the chemistry just for a moment here, the polarity of the material that's in these lubricants, the contaminants that are generated from oxidation, are really more attracted to the mechanical surfaces than the oil itself. You think about that. So SVR is really sacrificial surface area that you can put onto a system on a full-time basis so that it's easier to change the filter out than a bearing or a servo valve. And we've advanced the technology to that point where we are essentially sacrificial surface area, donating surface area that preferentially attracts what you'd never want on your mechanical surface. When you install SVR on a permanent basis on your system, it can't ever deposit on your mechanical surface. It's impossible. So this is sort of the step change in thinking and in terms of transitioning maintenance to a much more proactive role. You introduced the topic of oil analysis, and I get a little hot under the collar on this topic because users are expecting something very different from what they're receiving. And as a starting point, if you're starting out or trying to improve your program, it's like, can you show documented compliance that you're in industry specification? And I know that sounds simple, but it's not. And I'm going to tell you right now that half of the industry, if not 75% of the industry, cannot document compliance with industry standards. You think about that. That is unacceptable. You go into the oil analysis head first and you realize right away that the oil analysis packages that are being done right now are grossly insufficient. And to go so far, I would say, a diesel engine is very different than a gas turbine. Yet, why are they using similar oil analysis packages? And it's like the lowest common denominator. $60 is what I have to spend. What can you test for me for $60? It's like, well, not what you need tested. What needs to be tested is very clearly been published. And this is the industry standard, and it is also a specification. And, you know, my second rant here, this is turning into a little bit of a rant, is that you're doing oil analysis, yet the lab is very likely not following the test standard. You ask yourself the question, how is that even possible? But that's what's happening. The varnish test is a 100-hour test. And if the longer the oil is in the sample bottle, the higher the MPC value will be. So for this reason, it has to be reset. But then now it takes 100 hours. So you reset it by heating it. It's 98F for 24 hours and aging it for 72 hours in a dark place. That's not an easy test for the lab to do now. But I'll tell you what, if you don't do that test, your results are meaningless. And you're going to chase false positives. You're going to deploy maintenance dollars on the wrong machine. And while you're doing that, you're going to miss deploying the resources on the machine that's most critical to your business, that's up spec. So as a starting point, make sure your testing is actually done to the standards. You're doing the right test at the right interval. And then you can say, oh, I'm either in specification or I'm not in specification. And that's the starting point to all maintenance programs. But I find that, how is it even possible that users aren't at that point? So I'll end with that. We are at the point now where the chemistry of lubricants can be managed. And when I say that, that's not something that just happened. It's been a 30-year journey to get to the point where we can look after acid, we can look after varnish, we can look after demulsibility, we can look at rates of additive depletion. So it's really not a varnish solution. I mean, varnish is one of the side effects of managing the chemistry of your lubricant using SVR technology and ICB technology. But really, you know, it's a step change forward. So lubricant chemistry management, your lubricants are either in a state where their chemistry is managed or the chemistry is completely unmanaged. So it's a different thinking, it's a different step. It's a different way of managing and looking after your lubricants.